Okay, so we are going to just move on to the last speaker for this session before we have a little break to come back for the second session. We've got Sophie Thorogood from Pelsis talking about evaluating efficacy of insect light traps. So Sophie, how are you doing?
Good morning. Yes, I'm doing well, thank you.
Good, great stuff, great stuff. So yeah, insect light traps. Tell us a bit about that and yeah, what can everybody watching learn from yourself today. So thank you for being with us.
No problem. I'll just share my screen. Hopefully you can see that.
Yeah, I can see your main. Oh, there we go. It's
There we
it's up.
go. Perfect. All right then. Well, yeah, thank you for joining me today. I'm just going to give like a little bit of information about, what goes on actually when we talk about testing insect light traps or fly killers. We work with them, pretty much every day. Most sites we go to, there'll be a fly killer on there, or as we're trying to adapt the insect light trap terminology. And that's more about like emphasizing their monitoring devices, not killing devices. So an insect light trap helps you to monitor your fly population and not just kill them or control them. Okay. And yes, so I'll be talking about some of my experiences. I'm not trying to not give like everything away, of course, because some of the stuff we talk about, I know some other people watching, they might be doing some of this at the moment. Some people do a different way of testing as well. But I'll give you like a bit of a background of like what is actually happening behind the scenes. Okay. So when you think about a lab test, you might think about everyone dressed up into the nines in their lab coats, gloves. We're working with like beakers and glassware. We're measuring tiny amounts of different solutions, and it all looks very scientific. Actually, on a day-to-day basis, when you're working in an insect lab, it's quite messy. There's lots of bugs around. There's lots of like bits of food around for the insects. You try and keep it as clean as possible, but it's not quite as sterile as we expect with a lab environment that we normally think about. And it normally smells a little bit as well because the insects do produce an odor over time. And when we're doing insect light testing, we're doing it for a few different reasons. We want to basically understand how are the units performing. So how quickly are they catching the flies? And we have that testing for a whole host of different reasons. So firstly, you might want to compare your different sources of ultraviolet light. We know we are shifting from our fluorescent lamps to our ultraviolet lamps. We've got to because the sale of fluorescent lamps is being restricted in the next few years. And so when that happened in the past few years, there was a lot of development done in many different companies about actually trying to utilize this new UV source. It doesn't quite behave in the same way as a fluorescent lamp. It is as effective. I'm always going to say that it is actually as effective at catching flies, but how you maybe like use the source of UV might be a little bit different. So, for example, like you might have to have a glue board closer to the ultraviolet source, or you might have to change the tackiness or the stickiness of your glue board because the LEDs do run at a lower temperature. You may also have to think about the angle of the light. So usually with a fluorescent lamp, you get a 360 emittance of the lamp. But of course, with a UV lamp, with an LED lamp, you get more of a restricted, more of a cone shape creating from the light coming out. Okay. We also, of course, test competitor units. Everyone does it. We see how ours do, and then we test it against what someone else's does. And that's just it's mainly to give you an idea of like how is ours performing as it should be compared to others? Is it doing slightly better, which we always like to hear. But that's another reason we do insect light trap testing. The orientation of the units. So you have some units that, as you can see in the picture, are like either vertically placed. Sometimes they're horizontally, so you switch it around. And sometimes they're hanging. And does that insect light trap actually work in each configuration? We don't want to be producing a unit actually only works in one type of orientation. So maybe it works best as a hanging unit, and it works really poorly on the wall. This one doesn't, by the way. It works really well in all orientations, of course. But we definitely don't want to have a unit like that. Otherwise, when someone puts it on the wall and it doesn't work, it's not going to be very good. We also maybe compare the number of lamps in the unit or the amount of UV light coming out of it. So you can get usually like ones with less lamps in for smaller areas and more lamps for bigger areas. So your coverage can be increased. So how does the fly catch change with the number of lamps being in the unit? Of course, we want them being as efficient as possible in the amount of light they produce and the running energy costs. But actually, in a big area which is brightly lit, we're going to have to need more lamps in the unit or maybe a higher light output from the unit. Other things that, of course, also affect the performance of an insect light trap is the color. Here I've got some whites and silvery ones, but actually like the color does make an impact, and usually you want to have a more contrasting unit. So something that's got more of a darker outer surface that usually does a little bit better. And that's only because most of the time when we put the fly killer on the wall or the insect light trap on the wall, it's on a white surface. Most sites will actually have a white wall. So that's why one that has a darker cover usually does a little bit more better, because flies see contrast very well. They like a distinction. And if you ever watch flies moving, they actually normally land on that kind of like line right between a very light and very dark object. They love that little bit of contrast. Okay. And we have to do testing, and we have to put flies in a room with fly killers because we don't see how flies see. This is an image. It's not a perfect image of what a fly sees, because actually flies don't see red light and they do see UV light, which we can't see. We have no idea what the ultraviolet looks like. But this does give you an estimation of like the blurriness compared to our human vision. We can see much more, see in a lot more detail compared to flies. So we can see like the pictures on that cupboard on the end of the wall, at the end of the room. But to a fly, it's very blurred. And that's when I talk about contrast, because that actually would be more noticeable for the fly in the environment. But we can't ask the fly, did you like that fly killer more than that one? We don't know at what point will the fly start to be attracted to the fly killer. So that's why we have to do testing to make sure that when we do release flies into that space with an insect light trap, they actually do go onto it and they get caught. And we do need to have insect light traps that catch flies quickly. That's the whole point of the insect light trap. We want to take it out of the environment as quickly as possible. That, of course, is really useful because then the fly is going to be touching less surfaces. It's going to end up in less places where it could contaminate food or your food surface. So we want to make sure we have a quick capture of the flies, and then we also contain them. So we don't want them flying off again. Don't want to track them in and then them to fly back out. We don't want parts of the insect breaking off and actually contaminating the environment as well. Yeah. So you might have seen this video before, but I really like it. And it just shows how a fly feeds. It might make some noise, I'm afraid, so I'll try and mute it. There we go. I won't play the full minute. I mean, we can if you like, but I'm aware that you might not want to watch a whole minute of the fly feeding. But what you could see there was the fly. It's got its spongy mouth parts coming out and it's sucking up the liquid, the food source. Now, whatever the fly has been feeding on previously has now ended up in that new fly source as well. So whether it's been waste material in a bin, maybe it's animal excreta, maybe it's just human food, but whatever is a past meal has come onto that new food. So that is really important message when we're testing insect light traps. We want to make sure that fly doesn't get any chance to contaminate that new area, that new food source. And they're really good at also like preventing them moving into more risky areas in your production. So ideally you'd have a fly killer before to catch any insect before they entered a very high risk area where you wouldn't want to have any insects whatsoever. And so that's why they've got to be very attractive. They've got to capture the fly really quickly when they enter that environment. Oh, wrong way. Okay, so that's the reason why we're testing all the fly killers, and a little bit about why we spend so much time dedicated to actually testing this unit against this unit. We want to understand them better, and it's all to make sure that we're preventing public health issues with the flies. So when you want to test your insect light traps, we've got some main issues that we come across. So one, getting your supply of insects. We have many of these insects available to us in the field, or we come across them on a daily basis when you're on your different sites. Some places you go, there's hundreds of flies. But what we need to do is actually rear them up in a lab setting. We need to have enough of them so we can test them, and they've got to be of reasonable health as well. Okay, so there's some skill behind that of actually raising the insects, growing them to sufficient numbers. We next need to count the insects, and some of the times they're very fast. So there's some methods behind that of actually how do we slow down the insects, how do we immobilize them, and to the point where we can actually count them. You can't just like open a box of flies into a room. That's great, but you have no idea how many flies are in that box. So you've got to be sure about how many flies you actually release, or how many test insects you release into a test space. And talking about test space, what is your test space going to be? You want to have it contained enough. You want to make sure there's no alternative sources of light, like from windows, or you want to be able to control the light in that space, control the temperature, all sorts of things like that. And maybe, I don't know if it's like the most important thing, but you don't want to let them escape. One, you could have your own infestation originating, but you want to make sure we're not leading to other problems and affecting other people who might be in the building or nearby. Okay. So, like I said, you've got to get your insects. They need to be healthy. So here I've got an example of a fly on the right with some curly wings. This happens occasionally with breeding flies over years and years. You might get an anomaly turn up, and they might not get enough nutrients, or might be genetic influence, but you get wings with curly wings, you get flies with curly wings, and that means they can't fly very well. That's not so good if you're trying to do a flying insect test. They will still probably crawl towards the insect light trap, but it'll just take a lot longer, and they just wouldn't be suitable for testing. They've got to be mobile. So talking about them healthy, mobile, make sure, you know, they're not still a bit snoozy after we've immobilized them. We want to make sure they're actually moving very quickly and responding like a normal fly would be. You don't want them too young or too old. You actually get a decrease in fly fitness over time. So you want to make sure they're nice and healthy age. And if they're too young, you might have the wings not being fully dried out. So when they emerge, they need to actually dry out and unfold their wings. So you want to make sure they're not too young as well. And lastly, you've got to have enough of them. It seems so important. It seems so obvious that you want to have enough flies, but if you get to like 45 flies and you actually need 60 flies, you can't do a test. So we've got to always make sure we have enough flies. And I've got some maggots here. Here's my little maggot supply. They're having a nice time feeding on the food. And whatever I put into that food has to also be nutritious enough. So we've got some protein, some sugar, and that makes nice, healthy adult flies later. So there's a lot of different steps you go through to make sure you actually have your insects which are suitable for testing. You then need to collect your flies. So here's a little video of my flies in a box. It's just a little, we call them a little insect cage. You've got some water in there, you've got a little bit of food for them. And here I am going to collect some flies. And luckily enough, they like to be at the top of the cage. So it's easy enough to catch them. So I have no idea how many flies are in there. I've caught some, but I don't know. But you've got to be able to catch them somehow. Yeah, there's my flies. See, they're very healthy, they're very mobile, they're ready to fly. And so when you count your insects, I'd have no chance at the moment counting how many flies were in that little tub because they're moving too quickly and I just won't be able to count them. I'd end up with a rough estimation, but actually I wouldn't have a very exact number. So there are different ways you can to count your insects. So one of the easier ways could be that you count them in their pupa form. So here on the left, we've got some fly pupae. And of course, they're not going to fly away at this point. They're very easy to handle. And you can count them out into a tub or a little cage. And then you know exactly how many flies are in that cage. The issue with that is that flies actually emerge at different rates. So you might end up with flies that are emerging 2 or 3 days earlier than the other flies in that cage. And that's not real great when you're doing fly testing, because when we talked about you got to make sure they're not too old or not too young, you actually want to make sure you know exactly how old the flies are when you're testing. But if you're less specific about the age of flies, it might be a more easy solution to count them out like that.
That sounds mute.
Another way is you could use carbon dioxide to anesthetize the insects. That works very quickly, and what we say is we knock down the insects, so they actually become immobilized and that they become on their back, they can't fly, and then you count them out quickly before they come round. And that's a very quick and very easy method. You can only actually do that once. You can't do it multiple times because that affects the health of the flies as well. Or you could just cool them down. So we know insects have a warm, they rely on the warm environment to move, and they can't regulate their own temperature. So if you make them cold enough, again, they stop moving, and you can actually count them out that way as well. Okay. And then once you've counted your insects, you need to release the insects. Now, you've got to make sure whatever your space you're testing them in is big enough. Unfortunately, when you do any kind of insect testing or insect rearing, there's not these massive cages that are created just for you. So a lot of the insect cages that are commercially available are very small little cages like you saw I had my flies in earlier on the table there. You can get ones that are used for different purposes. So here's an insect cage on the right, and that's actually more to protect plants from flies or other insect pests in the garden. The bigger, it stops the flies getting out of the cage, but they have some limitations. So for example, this one doesn't actually have a floor to it. So you'd have to actually manufacture a separate floor to go into that fly cage to stop the flies crawling out underneath the net at the bottom. But that cage is just not very representative of actually a space where that insect light trap would be. So usually when we do testing, we actually do it in a room, and that's usually a room of a reasonable size. We're going for at least 2.5 meters. It'd be great if we had some massive rooms to test in, but it's just not very easy to convince people that you need a really big warehouse just for fly testing. And that room, usually we know exactly what the light level is in it. We know what the temperature is in it. Usually the lights might be on a timer as well to mimic like a working day. So the lights go off, it gets dark in the evening. The fly room might also get dark in the evening as well. Okay. And then of course, you don't want to let the insects escape. So one of the best things, of course, is a fly screen that helps to keep them into the area. We also usually have some insect light traps around the place to catch any escapees before they go off and go elsewhere. So they'll be outside of that test room. They'll be somewhere nearby. One of the best things is actually a fly swatter. I know that sounds very silly. We have all these like fancy insect light traps, but when you want to get rid of flies quickly, a fly swatter helps you do that, and especially between different reps. So you may do that once, you might release your flies, you have a test period for a few hours, maybe longer, but after that you need to kill off any flies remaining in the room before you put your new flies in. And that's where a fly swatter comes in really, really handy, to actually kill off anything remaining in the room. And also having quick hands. You know, the insects move quickly, so you've got to move quickly as well. There's always going to be one that might escape. So I'm not just thinking about insect, talk about flies, but there's other things. You can be quite quick to make sure they actually stay where they are. And then of course we repeat. We can't just do a test once. A minimum of 3 times is recommended for testing any product. But actually, if you want more meaningful data, it's usually better to do more like 5 or 6, maybe even 10 replicates, because then you have a much better idea of how that unit performs. And you kind of like get rid of any outliers of data. Flies behave however they want to, and they might not behave in every replicate. So if you had 1 replicate out of 3 where you had some odd data, it kind of ruins the whole data set in a way. Whereas the more replicates you have, the less likely it's going to influence like your mean fly catch or your average fly catch. And you can also exclude the outliers if they are really looking very strange. So maybe the flies were just a little bit too cold, or maybe they had too much CO2, so they didn't wake up properly. So you can exclude them if you have enough other replicates. Okay, so that's how we do a bit of lab testing. I hope that was useful. I do have a couple of extra slides just on field testing, mainly just to show it's actually quite tricky. So what we have in the lab, it's not usually it's not the same as actually having an insect light trap in a field or a proper site. So we want to make sure whenever we test, it is representative. And field testing is considered a bit more realistic of the product. You know, we can put them in a place where you have flies entering over time rather than flies we just release in. You can get a different mixture of insects turning up as well, which is really useful. So the problem with field testing, though, is actually, one, having to find the pests in the field. We know the pests are everywhere, but you have to wait until you get the pest in a specific location that you are interested in. So normally we come across sites where they have a recurring issue because they might be a bit more open to having some testing done, but also we know the pest is there. We also have to think about the permission we need when we are on site. So we need to be able to access the equipment at a reasonable time. So, you know, we have to get permission from whoever is on site so that we can actually come on, and also bring in certain bits of equipment. So there are sites that have regulations about you can't bring on certain things with Wi-Fi connectivity because it will interfere with their own system. And another big part that we kind of think about, but we can't really address properly sometimes, is how do you test a control? This might not be exactly with insect light traps, but if we had a problem pest like bed bugs, and we had a new solution we want to put into that location, and we want to see how effective it is compared to doing no treatment, that's quite hard to convince to someone to take part, because they might end up with more bed bugs or more of a pest issue, and they'll still be bitten over that test period. So it's a little bit hard to convince some people for certain tests to take part as well. And so certain things that can be an issue when you're doing a field test is finding the right type of site. So here we've got a pig farm. We had lots of flies, which was great. We had a power supply, which is also needed, which is a thing you don't think you have to think about, but you need enough power supply. But unfortunately, in this case, we just had way too many flies. And so that's why it wasn't a suitable location to test in. This was actually caught within like a couple of hours. And so the problem with this site was, even though we've got lots of flies, we can't see a true efficacy point of view. Like, does one unit perform better than the other? So we wouldn't have been able to tell if our unit was performing better than a competitor unit, for example. So that's one time where it went wrong. Another time, we tried a different site. Again, they had a fly problem. The flies weren't as big in number, like they weren't just around you all the time. You didn't notice them as much. Again, we had permission to be on site. We found an electricity supply. We managed to put up one unit just to do a little evaluation. But the problem with this site was it had a big door. And really, this is not a good place to put an insect light trap. It's just way too open and not very good. And so when we looked at our glue board the next day, we are getting some catch, but we're not getting the right types of insects this time. We're just not getting enough of what the pest insects would be, such as like our house flies, our blue bottles, any kind of like midge that we would want to control. Instead, we're getting things like there's some natural insects, so maybe that are found in the environment. So we've got some crane flies there, some moths, things that just aren't really pests. So we decided again that wasn't a suitable location. What we ended up doing for often enough is actually we have warehouses which work really well because they're a bit more representative of sites where we might be putting an insect light trap in the future. And we often find sites through friends of colleagues from Pelsis, but we also get them from customers. So this is my little plea at the end to say, like, if you'd like to be a part of like any kind of testing in the future, do let us know, because actually we'd be so keen, because we want to understand our product better and make sure that they work really well. So yeah, that's it from me. I hope that was useful when I talk about just insect light traps and what kind of goes on.
Great, thank you, Sophie. Yeah, that was some insight into light traps. I've actually quite a few questions about the positioning of fly units and what size unit to get for certain areas and things like that. There's a lot of details that come along with the manufacturing side of things, and they can, they read the instructions, it'll tell them there pretty much, won't it? So we've got one question just come in regarding lesser housefly. So if they're not especially attracted to UV light, can you add anything to light insect traps to make them more attractive to this species and monitor numbers effectively?
So there was a bit of research done, I think it was a little while ago now, but they looked at what attracts lesser houseflies into insect light traps, and they found that like green light was actually quite useful for helping to attract the insects in. So there are products on the market which give off like an ultraviolet and a green light, and that supposedly helps to attract the lesser housefly in a bit more.
Mm-hmm. So well, most of the suppliers out there of the people in the industry, will they be aware of these traps and be able to advise them if they get in touch with them?
Yeah, so we sell them.
Okay.
So if you look for like a synergetic lamp, usually that's got that green light in it that should help attract the lesser housefly in as well. Yeah.
Great. Yeah, I used to get quite a lot of those on the site. I had around Leeds. It's on like the green belt of an area, and they had a farm not too far away. So whenever they were muck spreading and things like that, I'd normally get an increase in them. I would actually catch them a lot of the time in some of the machines that I had, but I can't remember which machines they were. Maybe they had that green light there as well. So great. That's all the quote. No, we've had one pop in quickly from George. Are there any specific test sites you are interested in?
Oh, I mean, I'd be interested in anything, I think. And there's always like something out there we'd like to test. But yeah, anywhere where we're allowed to be on, like if you've got a rat issue, a mouse issue, bed bugs as well, like that. I know that's quite hard to come by because actually, yeah, like I said, people don't want to have bed bugs just not controlled. But like, and they want to sort them out as quickly as possible. But yeah, anywhere we have permission to be on, we could like usually it'd be nicer to be in like North Yorkshire because that's where Pelsis is based, but we do have a lot of other colleagues around the UK as well.
Would you be able to pop the best contact details in the chat section for anybody that's interested in, you know, getting involved a little bit more?
Yeah, of course, I'll pop that in now.
Fabulous, great. Well, I'll leave that. No other questions in there. And yeah, just want to say thank you again, Sophie. It's been a pleasure.
Yeah, thank you very much. Thanks for having me.
No worries. Take care. Have a great day.